So I'm now going to talk you through the 2019 transformation geometry question. Now, what we have with it is we have our setup here in the exam paper question. Make sure always when we get these that straight away we read it. So we have the figure shows the logo for a lighting company. The logo is subject to transformations in the following order. So we have an axial symmetry from P to P1. So from P to P1 we have an axial symmetry. Central symmetry from P1 to P2. Translation from P2 to P3, and then a rotation anti-clockwise through 90 degrees from P3 to P4. So there are our transformations. It says to draw the given figure and then determine and draw the image of the logo under the above transformations. Okay, now first things first, when it comes to setting all of this up, we need to just be aware of one thing in the actual setup of the question, and that is that we have two lines here. So we have one line here and one line over here, which are tangents to this circle. Okay. Now the thing about it is that when you get a question like this with transformation geometry, we need to make sure that this is set up properly using the proper construction. So we need to use a tangent construction to draw this properly, okay, before we can move it anywhere else. And then obviously we put in all of our different points. So to start off then, what I have is the general stuff put in here, but I've just left out my tangent construction here. And we'll remember that for our tangent construction, what we have for it is that we join the center to the point. So the point outside is down here. Okay, so we have our point down here that's going to join to. And what we're going to do then is we have it joining from the point here to the center of your circle. We then bisect that line. So we'll bisect our line here, and whoops. And where that bisector then hits, I'm then going to swing my arc. Okay, so I'm going to swing then from here. I'm going to swing to the end, so to the center here, and I'm going to swing my arc, and that's going to give me my 2 points of contact. So I have a point over here and I have a point over here, okay? And then that's going to allow me to draw in my tangents here to the side. Whoops. So we just want the bits that are going to be heavy. So just about that extra heavy line I put in there. Okay, and then I'll just go over my circle heavy. So to my 2 points contact. Now, when you get one of these as well, what's a good idea is to just label the points that you actually want to bring with you, okay? Because what we have with these is that we don't need to bring every point when we're going to all the different views. So it's a good idea just to label the ones that we want to bring. We'd be labeling anyway, but we don't want to label all the points, just the ones you want to bring around. So I'm going to have P, then I'll have, let's say, A, B, C, and P, and we'll want this one in the middle, so we'll call that D, and then we want E, F, G. Okay, so they're the points that we need. Once we have all those points, we'll be able to draw everything else. So I don't actually need these two, because when I have D here and F and E, I can just join them every time I get to a different place. Okay, so after that, then we start off with our first one, and our first transformation is an axial symmetry from P to P1. Okay, so from P to P1, an axial symmetry. Okay, so P to P1, axial symmetry, we need an axis. So like I said to you the last day, what we'll start off by doing is I'll join them up to each other. I won't actually do this in any color for now, so we'll join these up. Then I'll bisect my line because I know that the axis has to be directly in between the two of them. So I'll get my axial symmetry there, and then I'll put in my axis. And your axis for the axial symmetry is heavy, so there is my axis for my axial symmetry. Okay. Then we do the question the way that we would always do an axis symmetry. So I'll take each one of my points, I'll project them through, and then put my distances on. And make sure as you go that you label them as you go. If you label them as you go, then you'll be sure that you have the right points in the right lines. And actually, just realized here, having looked at it, we can actually leave these out for this one, because you'll see in a second what happens when I draw in my circle. So once I have my lines drawn in here, my points put in here, then I'm going to join them up. And obviously you'll take your time doing this to make sure that your points are in the right place. So as I go through this, there might be a little bit of inaccuracy with mine, but I'm just trying to go quickly so that I can show you this as quickly as possible. But what we have here is, if you look at it, is that F comes up here, hits my circle, so I could have F, and then E comes up and hits my circle, which gives me my 2 points. Sorry. F. Okay, so we need to be the same distance. So you'll see there that when you get a little bit ahead of yourself, it's very easy to put stuff into the wrong place. Okay, I didn't mean to do that, but it's a good example of that. So F and E. So just always take your time to figure out where your points are going to go. Don't try to just put them in without thinking about them. So then to find my line, then I can come along and I can get my line there and get my line there, and then I can put in my circle heavy. So that is my axial symmetry. Okay. Next one then is my, what are we looking at next? So next one is my central symmetry from P1 to P2. So I want the central symmetry here, which means I need a point. And we know that the point's going to be directly in between. So what we can do is that if I want a central symmetry from P to P2, I'm going to join up my two points. And then I'm going to bisect again because I want a point that's directly in between the two of them. And I get my point there for my center for my symmetry. And then I can go and do my center symmetry as I would normally do. Okay, so I'll bring all of my points through. Now, as I've said to you many times, if you're not comfortable with getting all your points in the right place from the start, then I would say for this bit is to do one at a time. So project it through the point, and then bring your point through, and then put your distance on it. And then after that, then go to the next one, bring it through the point, then put your distance on, and just do one at a time. Might make it a bit easier. So you'll see when all of these go in, I have a lot of lines on here, and it's about making sure that I follow the right ones. So just a small tip to make sure you follow the right one is that if I'm looking for the point D here, if I put my set square along the line for D, I can measure my distance and then put it onto the corresponding line down here. So I get D, and make sure definitely whenever you bring your points through that you label them straight away. So A goes through the point here, so you'll see there again that lines up. So I can then take my distance and put it down here. So, and this then for each one as we go through. So B then. And obviously take your time when you're doing this to make sure that you're accurate. So C. And then for G here, just center my circle. And then I'm just going to join those up before I bring E and F again, because it might save me a little bit of time. Okay, and then I'll put in my circle, just making sure to keep it the same radius. So I get, and you'll see here that they came, so from E here, joined up through my point, and I get point E, and I get point F, which lets me draw in my tangents. Again, as I say, take your time when you're going through all of this. I'm going a little bit quicker, so you might see there's a little bit of inaccuracy sometimes when I'm going through them. Doing pretty well so far though. So next up then is from P2 to P3 is a translation. So for a translation we need an angle and we need a distance. So what we'll do then is we'll say, right, we need an angle and a distance, so P2 to P3, join them up. That gives me my distance from P2 to P3, and it also gives me the angle that everything is going to project at. Okay, so that gives me the two things that I need. So what I'll do then is project my points, make sure it's going parallel. Okay, and then I'll take my distance on my compass, which is going to stay the same for all of them because it's a translation. So I'll have my distance on my compass there, and I'm going to bring them all the same distance. And as I do it, I'm going to put in my label straight away so that I don't mistakenly put a point in a place where it shouldn't be. Okay, so when I go to join it up, so C, E, and then my center for G, and I'll join those up. my circle. And then again, then I have E and F. Okay, so we're doing pretty well. It's deformed a little bit, but not too much. Then the last thing that we need to do is we want to put in our last one. So rotation anti-clockwise through 90 degrees from P3 to P4. So we're looking for going 90 degrees. So what I'll do is, on my sheet, I'll draw in my triangle as I've done before. So just down here in the bottom corner, out of the way, because I need to figure out what my angles are going to be. So if I need it to be 90 degrees up here. Okay, I know it's going to be an isosceles triangle. So what I can do then is I can say 180 minus 90, okay, is going to equal 90. And then 90 divided by 2 gives me 45 degrees. So 45 degrees is our important one for it to go down in the bottom corners. Okay, so 45 degrees there, 45 degrees there. And just to check again, does it want it clockwise or anti-clockwise? So it wants it to be anti-clockwise. So there's no harm in maybe writing it down here. So anti-clockwise, just to remind yourself. Okay. And what we're going to do then to make this one work, we're going to join up our 2 points. Okay. And like I said in another video, if we're going anti-clockwise, we're going to be going this direction. Okay. So anti-clockwise. So that would be putting my set square or my protractor down there. So I know then that my point is going to go up on this side. Okay, so I'm going to measure my 45s from the points here. 45 degrees one way. That's almost perfect there. And 45 degrees the other way. And actually, as it turns out, my point is up here. Okay, so what I have up there then is I've put in my 45 down here, 45 down here, which then gives me my 90 degrees up here and my center to rotate through. So last thing then is to rotate around my points. Okay, so what I've said to you about this a lot is that you are much better doing this one at a time. So I'll bring D, then go at 90 degrees. Now this really is the one where you want to really take your time, okay, because it's very easy to make your mistake here, particularly with your protractor. So D, so I'll take one at a time, 90 degrees. Now I'm actually going to speed up the video a little bit here at this point, just to shorten down the video a bit, just until I have all of my points, and then we'll look at joining it up. So then joining it up, then I'm going to join up my points. You see my B is, let me just check, so my B is a little bit off. quick check before I put it in. Yeah, so you'll see even myself, when I rush through these a little bit, they can make a mistake up in the rotation, and this is why, as I said to you all along, it's so important to take your time when you're doing these questions, okay, to make sure that you don't make the mistakes if you can get away with it. And as I also said to you, it's the reason they put the rotation last is because the rotation is the one you're most likely to make mistakes with. Okay, so there's my circle at the end, and then finally, just to bring my F and my E to find where the points of contact are. So F. And lastly, last point. E. And I get E there, and that then is the solution to the 2019 higher level transformation geometry question.